The following is the video solution from JSDT Solutions. Question 10 says, in the diagram, O is the center of the circle PSRT. TR produce intersects SV in V. ST bisects angle PTR. So we're going to have to look at what that is going to do to those two angles. And then they tell us that TS is equal to SV, as we can see. And then TOP, OS, and SR are joined. And the first question, 10.1, asks us to determine with reasons the size of angle PST. Okay, so we're trying to find the size of this angle over here. Now, notice that this angle is being supported by a diameter, okay, because it passes the center of the circle and touches the end of the circumference as a straight line. So it means that angle PST is simply equal to 90 degrees, and this is because of the angle in a semicircle. And that is our answer. Moving on to the next question. Question 10.2 says, determine the size of angle S4. Now, previously we found out that this angle is 90 degrees, and they want us to find angle S4. Now, in this situation, it seems weird to try to find a numerical value because they want the size of angle S4. They want us to find a numerical value, but they haven't really given us any other angles other than this that we just found is 90 degrees. So this is probably a case where angle S4 is 90 degrees or there's some sort of equilateral triangle here. Okay, so let's construct a way to find angle S4. Angle S4, where is it? Well, it's not really included in this shape, the cyclic quad, but it's outside the cyclic quad over here. It is, however, included in this triangle. So let's try to use this triangle to find angle S4. So to find angle S4, we would need to understand what exactly angle V is and angle R2. Okay, so right now angle V seems easier to start with because you see that they gave us these two sides being equal. So if these two sides are equal, we have an isosceles triangle, and we know that the angles opposite the equal sides would be equal. So these two angles would be equal. Okay, and we also know something about T2. This line ST bisects this angle PTR. So when a line bisects an angle, when something is bisected, it is cut into two equal parts. So that would mean that if this is cutting this angle, that angle T2 is equal to angle T1. So we'll keep that in mind. So let's go ahead and start off there. We'll tell them that these two angles are equal, and then that angle T2 is actually equal to angle V. Okay, so we're just trying to make a relationship, create a relationship between the angles here and possibly the angles in this triangle over here. Okay, if we can somewhat relate them, we'll be able to find out exactly what angle S4 is. Okay, if their angles happen to be equal. So let's go ahead and see. So we'll start off by telling them that angle T1 is equal to angle T2. So angle T1 is equal to angle T2. And the reason for this is because ST bisects PTR like they told us. Okay, and now that that is down, we're going to also tell them that they gave us that ST was equal to SV, right? And ST equals SV, and this was given. Now, because those are equal, it means that these two angles are equal. So we know now that angle V is actually equal to angle T2. So we'll go ahead and tell them that angle T2 is equal to angle V, and this is because of angles opposite equal sides are equal. Okay, so now that those are equal, we can now focus on, we found these two to be equal in each triangle. We can now focus on angle R2. Okay, so now we can finally conclude that that means that angle T1 is equal to angle V. Okay, so we're focusing on these two triangles and just finding out which angles are equal in both. So angle T1 is equal to angle V. So we can conclude. Therefore, this means that angle T1 is equal to angle V. And now that they are equal, we can focus on the other angle that we need to find in this triangle to better understand what exactly angle S4 is, would be this angle over here, angle R2. So let's focus on angle R2. How can we find the size of angle R2? Well, do you notice that angle R2 is an extension of TR? And TR is one of the sides in this cyclic quad, okay? This is a quad that has been drawn inside a circle with the 4 endpoints being on the circumference. Okay, so we can use this theorem where the exterior angle of a cyclic quad is equal to the opposite interior angle. So you see how angle P is actually equal to angle R2. So we can tell them that angle P is equal to angle R2 because of the exterior angle of a cyclic quad. And because they are equal, see what we have just found. We found out that this angle is equal to this angle. And we found out that these two angles are equal. So that would conclude that angle S1 plus 2, okay, that angle PST is actually equal to angle S4 because you have two other corresponding angles being equal in both triangles. Or really, it's just because of the sum of angles in the triangle add up to 180 degrees. So if this was like 30 degrees, and that was, so it's going to have to be 30, 60, 90, and that was 60 degrees, and you found out, oh, okay, that is actually 30 degrees, and that's actually 60 degrees. So that will conclude that this must be 90 degrees, okay? So that's an idea of that. Okay, so this means that angle S4 is actually equal to that angle PST. So angle S4 is equal to angle PST because of the sum of angles in the triangle. And we know that angle PST was equal to 90 degrees. So therefore, angle S4 is equal to 90 degrees. And that is our answer. Moving on to the next question. Question 10.3 says, prove that triangle TSO is similar to triangle TVS. So let's go ahead and highlight these triangles. So just remember that we found out that this is 90 degrees as well. Okay, so we'll just keep those in mind, and the other angles that we found were equal. Okay, so these are our two triangles. Now, in these triangles, if we have to prove that they are similar, then we need to show that all their corresponding angles are equal. So we already have two angles equal in both triangles. Angle T1 is equal to angle T2. So we have that already, and we can just tell them. We can tell them that we already know that, or we have to introduce the triangles first. Okay, in triangle TSO and TVS, we already know that angle T1 is equal to angle T2. And this was proven because we had ST being a bisector of this angle. So it was bisecting that angle PTR. Okay, and now we just need two more angles equal in these triangles. Do you see how this creates an isosceles triangle? Because we have a radius over here and a radius there. So this is an isosceles triangle, meaning these two angles, angle T1 and angle S2, are equal. Now we already know that angle V is equal to angle T1. So that would make angle S2 and angle V equal. Okay, so let's go ahead and state that first. We have to tell them that OT is equal to OS. So because they are equal radii, and because they are equal, these two angles will be equal. So angle T1 is equal to angle S2. So angle T1 equals angle S2. And the reason is angles opposite equal sides are equal. Okay, so if those two are equal, the whole point is to show them that angle S2 is actually equal to angle V. So we can also just mention that we already knew that angle T1 was equal to angle V. Okay, so I'm just going to mention that, but we knew that angle T1 was equal to angle V. So this would conclude that angle S2 and angle V are equal. So angle S2 is actually equal to angle V, like we have over here. We can see these two are equal. And the reason these two were equal, it was something that we already proved we're able to show them that we concluded T1 was equal to angle V. So I'll just say that this has been proven. Okay, so we've got two angles in each triangle being equal. And so that by default will make their third angle equal, since the sum of the angles in the triangles have to add up to 180 degrees. So that means that angle O1 is actually equal to angle, and that's angle S3 plus angle S4, which we can call angle VST. Okay, and the reason for that is because of the sum of angles in a triangle. Okay, so we've got 3 equal angles in the triangles. So that means that triangle TSO indeed is similar to triangle TVS. And it's because we were able to find 3 equal angles in the triangle. That's an angle, and an angle. So we can just tell them that's because of angle, angle, angle. And that is our answer. Moving on to the next question. Question 10.4, the last question for question 10 says, show that 2VS squared is equal to PT times TV. Okay, so the whole idea with this is we're going to find out where exactly these lengths came from and find out how it can end up being equal to this. So it usually has to do with the previous question. So we will look at those and just see the lengths that match here as well. Okay, so I've pinned it to the screen, and I'm just going to also take this because it's definitely going to be useful. And let's just see how this relates to what they have given us. Okay, so this is what we have. And we need to show them that 2VS squared. So where is VS? And let me just get rid of these highlights first. So with VS is over here. We have VS there. But it says VS squared. So there must have been 2 VS's that multiplied. Now with VS, we know that ST is also equal to VS. So they may have also used that. Okay, so first, let's go ahead and see how they match with this that we already proved previously. So in what we have to prove, we have VS. So let's go ahead and take VS. So you see that if we take VS, we have to take that with SO, the second and the third letter. So this will be SO over VS is equal to, and let's just see, is there any other length they took here? So here we have PT, here we have TV. So there's no PT, but there is TV. So TV is the first and second letter. So we also have to take the first and second letter. So that is going to be TS over TV. And let's just see if we can actually get here. So let's just go ahead and put this down and tell them that this is because we had similar triangles in the previous question. Okay, and the reason for this is because we have similar triangles. And we proved previously that those two triangles were similar. So that's what we have. And now let's go ahead and cross multiply and see how we can get this to look like that. Notice that TV is on this side. So when you cross multiply saying SO times TV, we can rewrite this as SO times TV, like that. And then when we cross multiply, this is saying 2VS. Okay, so that's VS multiplied by TS. So clearly what happened is, since we have TV, we've got TV here, they substituted something in place of SO. And over here, since we already have one VS, there was another VS that came about. But the only thing that is not here is that TS. So we need to find out what exactly are TS and SO equal to. So let's look at that. Let's look at TS first. What is TS equal to? TS is over here. So this is TS. Okay, and straight away we can see because TS was equal to SV, we can actually replace it with it, or let's call it VS rather. So these two were already equal, so we can tell them, but we knew that VS was equal to TS. So, and then we'll replace it. So let's just say, but we already knew that VS was equal to TS. So in place, we're going to put that there. So long what we'll have is VS multiplied by VS, which is VS squared. Okay, so that's where we get the VS squared is equal to. So we have SO multiplied by TV. So the only thing we need to find now is this SO. Let's look at SO and see what is it equal to. And it needs to somehow relate with PT. Okay, because that's what we have there. So SO is over here. And what is its relationship with PT? Okay, so do you see how PT is a diameter, SO is a radius. So it means that PT is twice the size of SO. Or we can basically say that SO is half the length of PT. And here's how we can put this down. We can go ahead and tell them that OP is equal to OT, which is equal to OS. And if they're all equal, then we can make that relation. So OP equals OT, which equals OS or SO. And then we can just tell them that these are equal radii. So that means that to get PT, we have to say PT is equal to PO plus OT. So add those two lengths together. So PO plus OT. But here's the thing. We know that PO or OP, let me keep it consistent, that OP is equal to SO. And we also know that OT is also equal to SO. So this equation can be written as SO plus SO, which is 2SO. So we know that PT equals 2SO. And now we're going to substitute. We need to put this in place of SO, but you can see that it's 2SO. So let's go ahead and get SO on its own by dividing both hand sides by 2. And so this means that SO is actually equal to a half PT. Okay, we can say that, or you can say PT over 2. It's still going to work out like this. So now we can go ahead and update our equation. So this finally means that if you take this equation and in place of SO we substitute this, then it means that VS squared is equal to PT over 2 multiplied by TV. And now you see that in order to get to this point, they just transpose the 2. We can also see this as multiplying both hand sides of the equation by 2. So we're just saying times 2 and times 2. And so this is simply equal to 2 VS squared, which is equal to, and here the 2's cancel. So we have PT multiplied by TV. And that is our answer. Okay, and that is it for question 10.